You will find the channel along with Ask Us Sysadmin, and a bunch of other good stuff. We started up a Gamer Edition deal last week. So yeah, now I'm going to show you something I worked on over the summer. This is for the people on YouTube doing a screen capture deal. All right, Hydra. Now, Hydra in Greek mythology was the beast with many heads, and you cut off one and three grow back. And this just looks like regular old boring Ubuntu. And that's all it's supposed to look like in user space. But something you can do with it that I find rather cool is boot up a dumb machine, diskless. I see this thing right here, SATA controller, nothing in it, CD, DVD thing, nothing in it. No possible way that it can boot with physical media on the virtual machine. But when you start it up and boot from LAN, give it a second. This thing only has a gig of memory. Yeah, it's booting Linux via PXE, the pre-executable environment. I really need more RAM in this thing. But yeah, we'll get back to that in a minute when my kids are born. Alright, so we have Hydra booting Linux over the LAN. Yeah, and we got Hydra from what was that movie? Yeah, Hercules. Yeah, I just found that on the internet. Thought it was cool. What? Okay, thank you, Mr. Grammar Nazi.
We're still waiting on this, right?
Okay. Okay, the uses. The uses for something like this is you can have a read-only operating system that a kiosk boots, like we have around here. They all use Linux. You can use it for work. If you, say, have a marketing department and they all require the same software, same everything, and they're using Linux, you can do it that way. I use this method for drive cloning. There is a software package called DRBL out there, which PXE boots the client and then runs Clonezilla to clone hard drives with partition level compression and other good stuff like that. And so yeah, you can also use this for troubleshooting. Oh, hey, it booted. You can also use this for troubleshooting a local OS, since you still have access to local drives and system resources. And on the same note, you can do data recovery off of those drives. And with it being Linux, you don't have the same risk of being infected with the same virus that maybe the host machine was infected with. Stuff to download. Obviously, you need to download stuff in order to get this to work. If on Ubuntu, I got this long ass thing you can type out, and everything will come to you. Would you like to? Sorry. Would you like to get this?
Yeah, we'll get back to this.
Okay. One of the things is DHCP server, and obviously that's for DHCP services. PXE relies almost entirely on DHCP for everything. Not only to get IP information and subnet information, but also to it also names a boot file for the dumb machine to boot. TFTP server, that's to serve up boot files, like all that text you saw in the beginning that just kind of went, you know, that'll serve via TFTP. Sys-Linux, that's to build the boot the boot image for the client. Yeah, I lost my train of thought. Sorry. Got out of it. Yeah, NFS server to remote mount folders. It's kind of like Windows file sharing, only it's a little more robust. You can share files in command line, and it works a lot better. Init RAMFS tools, it basically builds the boot image. So yeah, that's the stuff to get and what it does. The configs, DHCP-D, this is the config that I'm actually running now. Yeah, default stuff like loopback, I just cut out there. But you're setting up your own subnet divorced from the network around you. You set up the network address, the subnet. You give it a range of IPs that it can serve up, broadcast address. This is the address of the Pixie server to go and find this file via TFTP. And yeah, this config will not give you the Webernets.
Yes.
No. Interwebs, no. The tubes, no. ATFTP, this is pretty straightforward. I bolded what I changed in the default config. If you leave the use inetd equal to true, then every time your system reboots, it will ignore this file altogether. As I found out, that was a major gotcha that had me going around and around for hours trying to figure it out. And then here, I specified the TFTP boot directory as the place to go and find the boot files. The NFS exports config. Now, this is just one line. You can have many different images, many different lines on here for sharing stuff with NFS. But basically, it's directory, what subnet you want to share this with, and parameters. Now, if you change this RW here to just R, then you have a read-only file system. It will lock this directory from being edited by your client systems.
So like
squash, I have no idea what that means. And async, I don't know what that means either.
No root squash means no compression?
I don't know.
No, it does. It means no compression.
Okay. Okay, I'll buy that.
So what you're saying for, if you were just making a write, you would do that for like your kiosk or your workstation, work
Right.
terminal to keep the users from making system changes.
Right. And you can specify other directories if you want to add into your client image. Like if you wanted to map somebody's home directory to a network share, you can add this in. You can add that in here too, like /home/mat to some IP address, assume mats, and then all this other stuff. So you can give somebody read-write permissions to a folder, but give them read-only access to the file system. Pixie Linux. This is a giant pain in the ass. Yeah, it looks straightforward. It looks very innocent, but it's what's in these brackets right here that will throw you for a loop the first time you do this. Whatever your kernel version is. Yeah, I didn't think, oh yeah, maybe I should just go to the boot directory and look for the VM--whatever file. Just copy and paste that. But yeah, this is just telling Pixie Linux where to go and what to get, all that good stuff. If you have multiple images, you can have this file show a menu, like a grub menu, or lit or lamo menu, whatever magical prep work. Not getting into it. Basically, the end product is you set up a seed machine or whatever, a totally separate Ubuntu installation, and then you transfer the file system from that machine over the network to the NFS root folder, or whatever folder you want to call it. But yeah, it's a fairly mundane, boring task. All you got to do is set up an Ubuntu machine, customize it the way you want it, set permissions, install applications, whatever, and then transfer it all over the network to the server. Couple gotchas. Physical subnet. Now, in order for this to work, your server and your clients have to be on the same subnet, or the same broadcast domain, because that's the way DHCP works, is it broadcasts for, hey, you need an IP address, you need a DHCP server out there. Network speed. If you're not running gigabit LAN, forget about it. Over 100 megabits and lower, it'll take you 15 to 20 minutes to boot one of these things. The number of heads on the Hydra. Now, as the number of heads increases, so does the traffic on your network, because it's always going back to the NFS share and reading something, or getting a file, or writing a file, or something like that. And there's just way too much traffic on your network beyond a certain point, which I don't know. The configs, like I have complained about, they can be a real snake in the grass. Another thing, server outages. If you were to shut down the server while the clients are still running, all of the clients simultaneously will lock up. And that's not good for a work environment, necessarily. And there's a source, a how-to on how to do this from Ubuntu, but it's really incomplete and full of flaws, as I found out. So, yeah. Back to this thing. Oh yeah, the dumb machine.
It shut down.
No, it didn't shut down. Yeah, a totally separate Ubuntu installation booted over the network from the Hydra server, which also locked. Yeah. So, yeah, any questions?